Today, all observatories we see are run manually. By this, I mean that there is a human who is steering a telescope around the sky by pointing it towards a single object, but more often juggling between a list of them. He is constantly accounting for the movement of the Earth, the weather, the time, and the exposure. As you can see, this is largely a manual process and is therefore subject to a lot of human biases and errors. Collecting exposures for objects such as stars, planets, asteroids, and galaxies is fairly doable. However, searching for uncommon, irregular cosmic events like a sudden outburst from a black hole is extremely hard. More so, there's a well known bias called as the Malmarquist bias that says that humans are more inclined to look at brighter objects in the sky, leading to an observational sample that does not depict the entire population. So, in short, if I want to recapitulate the problem, it is that manual steering of telescopes, although in practice for centuries, is prone to lots of human error and biases that could be solved if we use an AI agent. This will optimize the performance of science experiments, reduce errors, and who knows, may open gates to brand new discovery. One way to solve the issue inherent in man-made telescopes is by using an AI agent and not a human. I am accomplishing this by using a reinforcement learning model. Reinforcement learning is implemented in areas that are normally uncertain, complex, and lack data. They are used to beat video games like Atari, Ping Pong, Battlefield, Go, etc. The two main elements of a reinforcement learning model are the agent and the environment. Each time the agent performs an action, the environment gives it a reward, telling us how good or bad the agent is doing in that game. In the end, the goal is to maximize this cumulative reward. Therefore, with more and more training episodes, the agent becomes better at that game and surviving in that environment. Therefore, if we want to make a telescope good at finding stuff in the sky, it needs to be good at playing astronomy games. This is something which is possible with AstroTact. AstroTact is a big package designed by DeepSkies Lab that simulates the sky. It offers environments to play a range of astronomy games like finding the equatorial surface of the sky or finding an emerging black hole. The game I worked on was where the agent had to find the equatorial surface of the sky and got rewards according to how good or bad it drew that. In the beginning, I made a reinforcement learning model that beat Atari games like Battlefield and Ping Pong. I did that for two reasons. One, so that I get more familiar with reinforcement learning myself, and two, because these games have a very similar environment compared to the astronomy games I eventually wanted to beat. Therefore, after that, using similar logic, I implemented the reinforcement learning model on AstroTact. The following slide shows us how a reinforcement learning model was implemented on an agent playing Atari ping pong. We can see how in the beginning the agent does not even know if it has to move, but towards the end it can move, it can hit the block and also beat the computer. The increasing reward values also indicate to us how the agent is learning how to play this new game and to survive in that environment. This graph shows us how a reinforcement learning model was implemented on AstroTac. AstroTac doesn't really give us a visual rendering, but the upward trending graph shows us how the agent is learning and is getting better at finding the equatorial surface of the sky. As of now, I only implemented a reinforcement learning model on one of the environments of AstroTac. However, this can be replicated for other environments as well that makes our agent more versatile. More so, after this is done, we plan to test our agent out on a real telescope at Stony Edge Observatory to see how it performs against the real sky.
In the end, I would like to thank Dr. Brian Nord, Eric Nielsen, Andres Hernandez, and everyone at Deep Skies Lab who helped me out and let me work on the self-driving telescope project. Thank you.